All right, so let's take a look at this fundamental theorem example. So they give us capital F of x equal to the definite integral from 0 to x of sine squared t dt for t between 0 and pi. And they ask you to complete a table, which I helped you with on Desmos, I hope you were able to see it. But then it says, also in that part, explain why f is increasing, or the values of f are increasing. So if we actually take the derivative of this function using the fundamental theorem, we end up with sine squared of x. Okay, because remember, there are two parts to the fundamental theorem. One of them, which works out to how we evaluate definite integrals by using an antiderivative and subtracting the value of the antiderivative at the endpoints of the interval. And then the other part of the fundamental theorem is an important relationship between the process of differentiation and the process of integration. And it gives us essentially an inverse relationship between the two, so that if we take the derivative of an integral, they essentially cancel out under the right conditions. The right conditions being that the integrand is continuous. And so this integrand basically just goes away and you replace the t that's in the integrand of sine squared t with x. And so f prime of x, capital F prime of x, is equal to sine squared of x. So it asks why the values of capital F are increasing. Well, remember that if the derivative, the values of the derivative of a function are positive, then the function itself would be increasing. And since we have a squared term here, we know that all of the values of sine squared x are going to be non-negative, greater than or equal to 0. And therefore, the values of capital F have to always be increasing. There are going to be, moments when this expression here equals 0, the graph goes horizontal for just that instant, but the graph is then going to continue on, and it would still satisfy the definition of increasing, of being an increasing function. So that answers that part of the question. Now, in part C of the question, it says to graph f prime. Now, I sent you that, so you should be able to, hopefully you can see that. It says, how is this graph related to the graph that you did in part B, which is the graph of capital F? And you should be, again, noticing that since the graph of f prime is always greater than or equal to 0, the graph of f is always increasing. And you can see there are, there are periodic times where f prime touches the x-axis, and the graph of capital F goes horizontal for that instant. So that's another connection that you can explain to help demonstrate your knowledge of the connection between the two. Now, the last part of this example, says to verify that the derivative of this function here, y equals 1/2 t minus 1/4 sine 2t, is sine squared t. So we need to differentiate this and show that it is sine squared t. And this is to graph y and write a short paragraph about this graph related to its parts b and c. Well, if we graph this, we should get the same graph that we got in b, and the derivative would be c, or the derivative that we graphed, the function that we graphed in c. And so those connections should be obvious. You just got to write and explain this. But let's go ahead and take this derivative. So, the derivative of 1/2 t is just 1/2, and then minus 1/4. Now we have to apply the chain rule here. I'm using the constant multiple rule for the first part, so that's why the 1/4 just comes down along for the ride. And then we're going to take the derivative of the outer function for this second term here. The outer function is the sine function, so we're going to get cosine of 2t. And then 2t is the inner function, so I'm going to multiply by the derivative of 2t, again, by the chain rule. And so if we do a little bit of rewrite here, we get 1/2. In fact, actually, now I'll do this in two steps. 2 times 1/4 is 1/2, so we get another factor of 1/2. I'm going to factor that out in just a moment, times cosine 2t. Now, we're going to have to use a little bit of trig identity to rewrite this so that we can see that we get the relationship that we want. But notice that each term has a factor of 1/2 in it, so we're going to factor out the 1/2 and we're going to end up with 1/2 times the quantity 1 minus cosine of 2t. Now, I'm not sure how well you remember your trig identities, and sometimes I wonder how well I remember them because I don't teach trig very often. So there may be one for the whole entire expression, 1 minus cosine 2t, but I'm not going to use that if there is. I'm going to use an expression for cosine 2t by itself. Now, there is a double angle formula for sine. So sine of 2x is 2 sine x cosine x, and then there are 3 double angle formulas for cosine. And so you may want to go look those up. Then again, I'm just going to tell you what the one is that we want. Since we're trying to get sine squared t, I'm going to use the formula that has sine squared t in it. So it's 1 minus 2 sine squared of t. That came off my tongue a little bit muddled, but so again, you can do a little quick Google search, or maybe your textbook has the trig identities in them. Cosine 2t is 3 formulas. One of them is 1 minus 2 sine squared t. Now, if we just do a little bit of simplifying here, of course, we distribute the negative sign here. 1 minus 1 goes to 0, and then the negative times the negative 2 sine 2 squared t gives you the 2 sine squared t in parentheses, and then, of course, times that half gives you y prime is just sine squared t, just exactly as they claimed. And so all we're doing here is we're making the connection. I got a blank screen in there. We're writing capital F of x, or rather they gave you capital F of x as an explicit formula instead of as an integral formula. So don't become too dependent on explicit formulas like that, because a lot of applications for calculus involves just being able to work with and deal with an integral formula, so it's not that big of a deal. You have the fundamental theorem as your major tool for utilizing that function and analyzing that function. So hopefully that was helpful.